Hello everybody, it's about 4:15 on Friday, January 20th, 2012, and this is a educational video on freezing rain, sleet, and snow, and how to forecast it. I'm making this video because this evening we're going to get some freezing rain, and we're already getting some freezing drizzle outside my house right now. Or I checked my windshield, it's definitely freezing. But the main thing, the main storm system that's going to bring this precipitation is this one right here, moving out of Kansas into Missouri, Illinois, and Iowa. So we got some heavy snow reporting in Chicago. Precipitation will continue to develop through the afternoon and evening hours and spread across the area, bringing freezing rain because the temperatures are in the 20s. Road surfaces are below freezing, and this will continue through the evening hours, bringing a nice coating of ice to the surfaces, especially untreated surfaces and bridges and overpasses and roadways that are much less used, like neighborhoods. So if you're out and about this evening, be very careful. Drive slow. Do not drive like an idiot because you may hit a patch of ice, black ice, and lose control of your car, slide off the road, and bam, that's it. I don't need to say anything more about that. But like I said, the main purpose of this video is to educate you on why we're getting freezing rain instead of sleet or snow. Some of you may have seen a graph like this. This is an atmospheric sounding. We use this to predict what kind of precipitation we are going to get. These are plotted using weather balloons, sensors that are on weather balloons. You've all seen weather balloons being launched into the air, either in a textbook or on TV or anything. You know, at the very end of these weather balloons are sensors. These sensors measure temperature, pressure, wind speed, and the dew point. And they're plotted on this. This is called an atmospheric sounding, or a profiler, an atmospheric profiler. Now, to me, just looking at this graph, I know exactly what we're going to get. We're going to get freezing rain. I know this. I can look at this for a split second, and I know this is a freezing rain chart. Now, why is that? Okay, first off, let's explain the chart real fast. These bars over here are the wind speeds. I mean, there's a wind speeds and direction. Wind's coming out of the west mostly with the trough, and you can see this with the graphic right here. National analysis. This is 500 millibars. Wind's coming out of the west. Plain and simple, easy. Okay. This bottom row right here is the temperature from negative 30 degrees Celsius to 40 degrees Celsius. This left-hand side here is your pressure or your height, your altitude. Starting at 1,000, this is actually the real surface, 1,013 pascals, hectopascals, or millibars. But in St. Louis, it's around 1,000 millibars. We are above sea level, so it's 1,000 millibars. St. Louis, and it goes up. This is 850, 700. This is about between 4,000 and 5,000 feet, about 4,500 or so. This is 700 millibars, or about 10,000 feet or so, estimated. These are all rough estimates. It changes every single minute, every single day. It changes. But a rough estimate of 9,500 to 10,000 feet. And goes up from there. This red line here is the temperature line. This green line here is the dew point line. And you put this all together, and you get an atmospheric sounding. Now, why is this sounding showing freezing rain to me, the trained eye? As you all know, or most of you know, precipitation starts as snowfall, way up in the atmosphere. And it falls to the surface, and it either falls as rain, sleet, or snow when it hits the surface. Occasionally you'll get graupel, but I'm not going to explain that. Okay, so why are we getting freezing rain? We're getting freezing rain because as you follow this temperature line down, first off, when the temperature and the dew point meet, that usually means clouds and rainfall, and it goes all the way down. When it's like this, you're getting precipitation to the surface. So this temperature and dew point meet around just below 700 millibars, about 710, 720 millibars or so. When this meets, you're going to have precipitation that forms in this region. Because it forms above freezing, it's going to start as snowfall. So we have snow around this area. Now, this line right here, I forgot to tell you, this is the 0 degree Celsius line or the 32 degree Fahrenheit line. This is your freezing line. Okay, so it starts to snow above freezing. Now, when this as it goes down, goes down the atmosphere towards the surface. It hits this line. It hits this freezing line, and when it passes up the freezing line, it melts into rain. Okay, you following me? Because it's on the warm side. This is the warm side. This is temperatures above freezing. On this side, it's temperatures below freezing. It's melting through this layer. So once the snowfall melts, it melts into a liquid raindrop. Okay? And as it continues to fall towards the surface, it continues to be above freezing. The raindrop continues to warm until it gets to about the atmospheric temperature, this maximum temperature of about, I say from this about 38 degrees Fahrenheit or so. So this raindrop through this layer is about 38 degrees. Now, as it continues to fall towards the surface, it hits this line again. It hits this freezing line again. And once it gets to left of this freezing line, the raindrop starts to cool. It starts to refreeze. But because it's so close to the surface, it doesn't have time to refreeze into a sleet pellet yet. Into sleet. It just gets cooler, but because it's below freezing at the surface, and because the surfaces are below freezing, once that raindrop hits the surface, and because the temperatures are outside of 28 degrees, it freezes. This liquid water starts to freeze on the surface, and that is what we call freezing rain. Because this warm layer, is so deep, and this cold layer at the surface is so shallow, the raindrop that started as snow and works its way to the surface, it doesn't have time to freeze again into a